to this specific equation, but in general, we're asking a question. That's the question that we're asking. What does the b do to the roots? And that has to do with what the b does to the period. And I just want to remind you, when I'm saying b, I'm talking about that number inside the parentheses. It's the same b from our general form. So take this down, and then let's continue. We're going to use substitution to solve this. But see if you can come up with your own sort of way to think about it. So instead of saying sine of 2x, which is what this is, we'll say let u equals 2x, and so we'll do sine of u equal to 0. We'll see shortly why, but you know where the roots of u are, because u is on the unit circle, so where is sine 0? That's our question. Right, so sine is 0 here and here and here, so that's at 0 and 2 pi and at pi. Now let's see what happens. We're saying that the solutions for u are 0, pi, and 2 pi. But we're not solving for u, we're solving for x. So if u equals this stuff, then that means that 2x equals this stuff. And how do I isolate for x? Exactly right, I divide by 2. So then I know that x is 0, pi over 2, and pi. But if I'm solving on the interval 0 to 2 pi, then I'm not done with yet. I've got to find all the solutions up to 2 pi, which means, well, I need to know something about the period, because the period is what I'll do. Remember, we add 2 pi usually. Well, the period here isn't 2 pi, it's just, it's not that. So let's see, the period is 2 pi over b, so 2 pi over, well, 2, so the period is pi. So I need to add pi to each of these answers, and that'll give me all of my solutions. So let's see what it would be. So I have 0, and 0 plus pi is pi. I've already got that taken care of. Now I've got pi over 2 plus pi. Oops, pi over 2. And pi. Okay, so let's see. This solution, pi over 2 plus pi, would be pi over 2 plus 2 pi over 2. So I've got 3 pi over 2, and then pi plus pi, 2 pi. So those are all my solutions. We'll do it again with another example. Before you do any of it, though, review your notes and look at the steps, and let's do those steps again. So we have sine 3x equals 0. We're going to do the substitution, so we'll say u is 3x. So now, sine u equals 0. Well, we just did that same problem, so we know that u, the solutions for u, right, are 0, pi, and 2 pi. All right. Now, what does the 3 do to the period? Well, it makes the period become 2 pi over 3. Okay, those are the things we need to know. And the solutions for u are this stuff. And I said u is 3x. Then 3x equals this stuff. Which means, again, to get like x by itself, I'm just dividing by 3. So I've got 0, pi over 3, and 2 pi over 3. All right? Now the caveat here, right, is that, look, if I'm solving for something, all I need to do is find sine on the unit circle, or tangent on the unit circle, and then look at the end. What am I really just doing? I'm just dividing those roots by 3. The last step, though, is I've got to add 2 pi over 3 to all of these solutions and see what I get. So do that on your own. It's fractions, it takes time. Solutions. I added 2 pi over 3 to each of the solutions from before, to these. Now, the caveat is, this was a multiple of 3, so I need to add 2 pi over 3 2 times to each of these. So let's do that. 2 times to that because I need 3 times the solution. So I've got the first set, and then my second set was adding 2 pi 3, and my third set was adding 4 pi over 3, or 2 pi over 3 twice. Alright, take this in. I'll give you one example. And if like the adding stuff didn't make complete sense, then all you have to think about it is you just keep adding the period until you get to more than 2 pi. That's the same idea. So find these roots and we'll check them on Monday. Tuesday, because today is Monday.